Hi guys, next I want to take a look at a theorem that we need to prove because we're going to use it a lot, and we'll also use one of the properties that we just finished looking at. But the name of this theorem, I call it the third angle theorem, and I know a lot of books call it that. So yours may not, but I'm going to call it that because it's so commonly referred to. What this theorem really says is that if you've got two triangles, first of all, and if two angles of one of those triangles is congruent to two angles of the other triangle, then the third angles, which in this case would be B and F, would have to be congruent. So that's what we're trying to prove, is that angle B is congruent to angle F, and I want to get that. I don't want to mark it from the beginning, because from the beginning we only mark what we know is true. So what I'm going to do is ask you to go along with me, and let's prove this as a formal proof with two-column formal proof, and then once we prove this theorem we can use it forever. So the first thing that we're going to have is what we're given, which I've given you in the mark. We're going to say angle A is congruent to angle E, and angle C is congruent to angle D. And that's what we're given. And what we're trying to prove, once again, is that B is congruent to F. Now I want you to think about this for a minute, and while you're thinking, I want you to just stop the tape, just pause it, and look at this and think about it. And this is a question I want you to think about. This is the first one. If A is congruent to E and angle C is congruent to angle D, do you think that angle B would be congruent to angle F? Do you think that it would? And then after you say, well, yeah, I think it would, or whatever you think, no, I don't think it would, but after you think about it, then I want you to ask yourself, do I know that angle B is congruent to angle F? Do I just know it would have to be? And then after you reach your conclusion on that, if you feel like, I know that B and F have to be congruent, then I want you to ask yourself, how do I know that? Why do I know that? And so you stop the tape now and think about that, and I'm going to continue, because you can just turn the tape back on when you're ready, but please take some time to think of that first. Now you're back, so you've thought about it. And the reason I had you think about it is this. Many times people think proofs are so hard, they're just so hard I can't do them. And one reason is this. You really and truly cannot possibly prove something, certainly not in a formal manner, if you don't even know it's true. So before you ever try to prove something like we're trying to prove B and F are congruent, take some time and first of all, think about it. Use your thinking skills and say, well, do I think they are congruent? Do I know they're congruent? Because you cannot prove they are. You cannot prove something is congruent with any confidence unless you know it to be true through your own reasoning and your thinking. So that is why I'm asking you on every proof we'll do the same process. So okay, we've got A congruent to E given, we've got C congruent to D, and I've asked you, do you think B and F is congruent? And I'm going to assume here that you think that B and F are congruent. Okay, I think they are, and I know they are. And then I said, well, how do you know? Well, I know they are because I know these add up to 180, and I know these three add up to 180. So if those two are the same as these two, then this would have to be. And so I hope that's the thinking that you went through as you planned out your proof as well. So let's write it down in a formal manner so everybody will understand how to do that. So if that's the train of thought we're going to use, first of all we need to say that these do add up to 180. And so we say that the measures, remember it's the measures that add up to 180. Measure of angle A plus measure of angle B plus measure of angle C equals 180. And the same thing over here. The measure of angle D plus the measure of angle E plus the measure of angle F also add up to 180. Now, if you're writing a formal proof, you have to put a reason over here. The reason is either a theorem, a postulate, a definition, or a property. So we're like, well, how do we know that? Because we had a theorem earlier that we proved more in a casual manner, but we proved that said every triangle contains 180 degrees, or the sum of the angles of a triangle is 180, however you want to say it. So I'm going to say 180 degrees in every triangle. And that can go with both of these. I can put them both in the same statement. I know that's true, so there's been no guessing going on here. Okay, next. Like, well, I want to get B is congruent to F. That's what I want my last step to say. B is congruent to F because that's what I'm trying to prove. So I'll say, okay, how can I get that? Well, look carefully at what we've got now. We've got these three angles right here stated for sure to be 180. And these three angles stated for sure to be 180. So that property we just used, transitive, really, or substitution, they're both equal to 180. So we can truly set them equal to each other. Two things equal to the same thing are equal to each other. So let's do that. Let's say that the measure of angle A plus the measure of angle B plus the measure of angle C, and I'm just going to stretch it out here so you can see it good, is equal to the measure of angle D plus the measure of angle E plus the measure of angle F. And that's our third step. So let's put our third step over here and put, again, how did we know that to be true? Because if we write it down, we have to have a reason that allowed us to write it down. And we say, well, they were both equal to 180. Two things equal to the same thing or equal to each other. So I can say transitive. And because I'm substituting into an equation, I could also say substitution. It really does not matter. There we go. Okay. So either one. Don't have to put both. So I'm like, okay, well, all that's fine and good, but what I'm trying to get is angle B congruent to angle F, because the third angle theorem says if two angles of one triangle are congruent to two angles of another triangle, the third angles will always have to be congruent. So I'm trying to get the third angles congruent. I'm trying to show that. So here I go. I'm like, well, I really just want to get B and F. I want to get B and F. I want the others to go away. So let's see if we can make them go away. A is congruent to E, so I can subtract the measure of angle A and the measure of angle E. I'm subtracting two things that are equal, one from each side. Subtraction property of equality. Okay, well, I know C, whoops, excuse me, I know C is congruent to D, so I can subtract angle C and angle D, one on each side. Subtraction property of equality. So what I have left is measure of angle B is equal to the measure of angle F. And again, step 4, how did I reach that conclusion? I did it by subtracting. So I go subtraction property of equality. So that's a good example of how we use that particular property. So we've got measure of angle B is equal to the measure of angle F. And so just to make it a little more complete, we'll say therefore angle B is congruent to angle F. And whenever we go from measures being equal to angles being congruent, we say definition of congruent. So now what we have ended up with is a statement that angle B is congruent to angle F, which it certainly is. So now we do know that angle B is congruent to angle F. And we have proven the third angle theorem, which says in two triangles, if two angles of one triangle are congruent to two angles of the other, then the third angles are congruent. If two angles are congruent to two angles, the third angles are congruent. We will use that a lot So we have proven it so that we can use it forever. We don't have to prove it anymore. It's ours to use now. It's one of our tools. So expect to use it, and I'll see you again soon.